This video is used to introduce a parallel folded dipole antenna. With enhanced bandwidth and compact size, it is a good candidate for millimeter wave wireless communications. Due to sharp variations in resistance, it is difficult to achieve wide working bandwidth for the half-wavelength dipole. Then, two half-wavelength dipoles are considered to be connected in parallel. The input resistance is significantly reduced, and a flat input resistance curve can be observed between two resistance peaks. This indicates that parallel dipoles features wide impedance bandwidth. An impedance bandwidth of approaching 80% can be realized when the port impedance is set as 70 ohms. To reduce the footprint, the terminals of the parallel dipole are bent inwards, constructing a parallel folded dipole. The bending terminals have only a slight effect on the input impedance. But the antenna footprint is reduced by 20%. The parallel dipole can be decomposed into two dipoles excited by a common mode signal. The relationship between voltage and current can be conveniently expressed using an impedance matrix, and the common mode impedance can be calculated. Considering the characteristics of the parallel circuit and network reciprocity, the input impedance can be further derived. It is clear that the input impedance of a parallel dipole is affected by the mutual impedance. Therefore, the spacing between two dipoles is a key parameter that affects impedance matching. Based on the concept of parallel dipole, a PCB-based parallel folded dipole is developed for planar integrated circuits. A simple feeding method is constructed by a coupling slot and two grounded metal holes to realize differentially excitation. Benefiting the broadband property of the parallel dipole, the proposed antenna realizes an impedance bandwidth of 64% from 16.7 to 32.5 GHz. About 1 octave band. For millimeter wave communication, a high-gain array antenna is necessary to ensure the link budget. The designed parallel folded dipole is expanded to a full corporate-fed 4x4 array by using a simple microstrip feeding network. An array prototype was machined and measured. The measured results shows an impedance bandwidth of 65%, a peak gain of 17.5 dB. Moreover, an antenna efficiency higher than 70% is realized. The measured patterns show good symmetry and low cross-polarization levels below. The proposed parallel folded dipole antenna exhibits good prospects for 5G millimeter wave applications.